Okay, in this video I'm going to provide a brief demonstration of how to carry out planned contrast following a significant um, test of the between subjects factor in a one-way analysis of covariance. So what I'm doing is pivoting off of some data from a previous demonstration. We have an independent variable or between subjects factor called intervention, where we have levels of 1, 2, and 3 representing a control group, treatment A, treatment B, respectively. We have the dependent variable post-test knowledge. This is treated as continuous, as is the covariate within the model, which is pretest knowledge. So basically, we're going to be including intervention and pretest knowledge as essentially predictors of post-test knowledge. But what we're going to mainly focus on is assuming that the effect of intervention on post-test knowledge after controlling for pretest knowledge is significant, then carrying out planned contrast in order to compare the intervention groups on the post-test knowledge means. Really quickly, let's talk just briefly about contrast. So basically, we can specify a contrast in the following way, where we have psi equals, and then we'll take the product of a set of contrast coefficients and the means for each of the groups. All right, so we'll have the product of the contrast coefficient for group 1 times the mean for group 1, and then we're going to add that to the contrast coefficient for group 2 times a mean for group 2 plus the product of the contrast coefficient for group 3 and the mean for group 3. So if I want to carry out a contrast, let's say of groups 1 and 3, their respective means, then what I can do is substitute values of the contrast coefficients into the C1, C2, and C3 places. So if I want to compare group 1 and 3, I can easily do that by just substituting a 1 for contrast coefficient for group 1 and a -1 for the contrast coefficient for group 3, and then a 0 for the contrast coefficient of group 2. So this reduces the contrast into the mean for group 1 minus the mean for group 3. Let's say that I want to compare my control group against the average of the means for groups 2 and 3. I can do that as well. For example, I can substitute a 1 in for the contrast coefficient for group 1, a -1/2 or 0.5 for the contrast coefficient for group 2, and then a -1/2 for the contrast coefficient for group 3. So when I do this, I'm basically taking the average of the means for 2 and 3 and subtracting that average of means from the mean for group 1. So in this particular case, if I do this, then I end up with, and I'll just kind of put a little arrow up here, then what I end up with is the mean for group 1 minus the average of the means for groups 2 and 3. Okay, so we can use contrast coefficients in SPSS in order to lay out our planned contrast. Note too that there are basically two types of contrasts. There's simple planned contrast where we're comparing the means of two groups. A complex contrast involves a comparison involving more than two group means. So you can see right here that the second contrast that I carried out was a complex contrast. So let's run our analysis using SPSS, and so we're going to go to Analyze, General Linear Model, Univariate. I'm going to put Intervention in the Fixed Factors box, Post-Test Knowledge in the Dependent box, Pretest Knowledge in the Covariate box. Under Options, I'm going to ask for a number of the same things that I typically ask for. I'm not going to spend much time on this because I kind of went over this in a previous video, but I'll click on Continue. And under EM means, I'm going to move overall and intervention to the display means box. And this is going to produce, when I do this, it's going to produce adjusted grand mean and adjusted group means for the dependent variables. So in other words, we are adjusting for the presence of the covariate in the model. And so when I carry out the planned contrast, it's going to involve comparisons involving those adjusted means. So I'll click on continue. I will note too that there is a contrast box that's available through the contrast tab right here, and there are various canned options that are available to you in SPSS. But I typically prefer to just go ahead and run through syntax. So I'm just going to click on paste, and you'll see that when I clicked on paste that a number of basically the options that I've specified through the menu, the syntax for those have appeared. So you'll see at the end of the line where it says \design equals the covariate name, pre-knowledge, and then the between subjects factor intervention, we have a period. So I'm going to remove that, and when I do, you'll see the uni ANCOVA up here turn red, and so so that's going to signal that eventually I'm going to need to have a period that closes everything out again. But I'm going to go to the next line and use the L matrix command in order to specify my contrast. And the first one I'm going to do is a contrast between groups 1 and 3. So I'm going to use \L matrix. You'll see it appears in green. And typically I like to include a title for the contrast. So I'm going to put that title in quotation marks. So I'm going to say group 1 versus group 3, and then end quotation marks, and you'll see that it turns from red to black, which is good. And then we'll hit enter and go to the next line, and then we type in the name of the independent variable, which is intervention. So I'm going to type in intervention, and I have my little capital I in there, so don't forget that. And then I'm going to type in a 1 space 0 space -1. And so that's going to specify the first simple plan contrast between the adjusted means for groups 1 and 3. That is the adjusted means for the control group and treatment B. Next, I'm going to type in, go to the next line, type in \L matrix, and then I'll type in control versus treatments. And basically what I'm going to do in this case is compare the adjusted mean for the control group against the average of the adjusted means for the two treatments. So next I'll go to enter, I'll hit enter and go to the next line, type in intervention, and then I'll type in 1 space -1/2 and -1/2 and then period, and so you'll see the uni ANCOVA turn blue again. Note that your contrast coefficients need to sum to 0, and so in both of these cases they sum to 0. So now we're ready to go. Also note that if I had wanted to, I could have made this -1 and then both of these 1/2s positive. So it's kind of arbitrary in that respect how you want to lay that out. But what we'll do is we will now highlight everything, click the green button, and you'll see that we have our descriptive statistics for post-test knowledge. These are unadjusted means. So these are the means for the control group, treatment A, treatment B, but they're not adjusted for the presence of the covariate in the model. We have Levine's test, which we still have the assumption of equality of variances. When we scroll down, we have our tested between subjects effects. We have the between subjects factor being tested with the analysis of variance right here. We see that there are significant group differences on post-test knowledge when we're controlling for pre-test knowledge. When we look at the effect of the covariate on post-test knowledge, we see that there's a significant relationship there as well. If we looked under parameter estimates, we can see that the regression slope is positive, indicating that there's a positive predictive relationship between pretest knowledge and post-test knowledge. And you'll notice that when it comes to the significance level right here, it's exactly the same. And in fact, the F value that you see right here is nothing more than the square of the t-value that's contained in these regression results. We'll scroll down and look at the contrast. So there's contrast 1, contrast 2. First one was named group 1 versus group 3. The second one was named control versus treatments. And for the first contrast that you'll see right here, well, actually, before we go to that, let me just kind of scroll down. You'll see that we have down here where it says estimated marginal means, we have the grand mean on post-test knowledge that's adjusted for the presence of the covariate. So you'll see right here that it's just saying that we're adjusting for pretest knowledge covariate. And so that's the difference between this grand mean and the mean that's shown above in the descriptives table. Same goes for the intervention, where we have the adjusted means for each of our three groups, basically adjusting for the presence of the covariate. So each of these contrasts are involving adjusted group means. So you'll see right here the contrast estimate. This is just basically taking the mean for the adjusted mean for the control group, subtracting the adjusted mean for treatment B, and so this is the difference in those means. And this is indicating that we have a significant difference. Basically, the adjusted mean for the control group is almost 3 points lower than the adjusted mean for the treatment B group. And then when we scroll down, we can see that when we compare the control group, the adjusted mean for the control group against the average of the adjusted means for treatments A and B, we see that we have a difference of negative 5.378. So the control group, the adjusted mean for that group is approximately a little bit over 5 points lower than the average of the adjusted means for treatments A and B. So, and you can see that we have our p-value indicating statistical significance. Note too that if you wanted to compute the t-value for these tests, you can just take the contrast estimate and divide by the standard error. So that concludes this demonstration.